Good morning, sir.
Morning. Thank you. So I think it works both ways already. My headphones are working, and my mic is also working. Can hear me? Okay, let's get started. Sorry for the slight delay. I was busy with some other things, some other work. So actually, I forgot the time. So again, before we continue, are there any questions from this Wednesday's lecture? I think we just introduced the some of the key concepts of rule-based expert systems. Right? We talk about a few things there. We talk about what is knowledge. We talk about how do you represent knowledge. Okay, and then we also, I think, introduce the motivation for why we want to look at what we want to do now, or how do we create? Basically, it's how to create your rule-based expert systems. So, any questions before we continue? Okay, just to refresh what we hope to achieve at the end of this topic. So we have covered last I would say last week, a few days ago. We talked about what is knowledge. We introduced the concept of knowledge, how to represent knowledge, and so we actually spend some time looking at the motivation, why we want to represent knowledge, so that we can build such expert systems. And we also look at how to represent knowledge, because if you say you want to build an expert system, because we understand that at the end of the day, the expert system, as the name suggests, is an expert. So how do we capture that expert knowledge into this artificial system, right? That is intelligent. So we look at using rules as a knowledge representation technique. And I think that's where we stop looking at the main place of the development team. So I think as I said, that we covered the motivation, what is knowledge, what is expert system, and how do we represent knowledge. What is the most common way? What's the most effective and common way to represent knowledge? So are there any questions before we continue? No? Okay. Please, as I said, please ask, because then you will not get confused. Okay. So we look at the example of how rules can be used. So it can also, for some of you, you might able to see, right? See that such expert systems, what value do they give us? They tell us that the car is dead, right? Your car cannot start because probably it's your fuel tank is empty. There's no fuel inside your fuel tank. It can also help you to recommend, and of course, it depends on your application, where you want to use it. So in this case, we actually look at in terms of example of maybe a tourist traveling to another country, to a temperate country, not the tropical. Like we only have, I think, 2 seasons in Malaysia, either wet or dry. So the temperate countries have 4 seasons. You have autumn, you have summer, you have spring, and you have winter. So in this case, if you are as a tourist, right, you want to visit the city and its sights and its sound and its food, for example, what should I do? So this is a recommended system. So I think you can clearly see that I can also apply such a system to other applications, other areas. So in this case, you look at the system will tell you the time now. What is it? Is it autumn or is it some other season? Then look at the sky. right? So the second feature is the sky. Is the sky cloudy? The one is, of course, you maybe rely on the weather forecast from the TV or even the radio, right? If the forecast, the weatherman tells you it's going to drizzle a little bit, I mean, a little bit of rain, then the advice is your system will tell you, please take an umbrella. It's better to take umbrella to be safe. Otherwise, you may get caught in a bit of rain, right? So there's the second application of your expert system. The third one is actually the directive. It tell you, please do something. It'll direct you to do something. So it's a directive, straight to the point. If your car cannot start, the car is dead, and the fuel tank is empty. So now you have checked the fuel tank is empty. So what should I do? This is actually useful. I think I can see this very useful. I think it's also has been developed in some of those high-end cars, right? Will tell you your tire pressure seems a bit low. Please stop the car and check. Or the tire pressure, your tire itself seems to be have no air, punctured. Please, if you want, you can carry on driving, but drive slowly. You can still drive, but drive slowly, or you can stop the car, right? So these are your directive. So in this case, if your car cannot start, it will tell you, and then you check, right? The system will check. The fuel tank is also empty. Then you tell you, please, if you want the car to move again, please pump in petrol to your car. So there's your directive. Strategy is actually as a two steps. Two steps. Step one, if the car is dead, action is check the fuel tank, and then after you check the fuel tank is not empty, right? Then you check your battery, right? So this is tell you that please do this, right? So I think this is something you've seen before. Now, where do you see this? Anyone can remember? Can also want to share? Where have you seen this? And I think this has actually been used quite widely, and I would say also quietly. I think you're using this and you don't realize that, right? So this is what does this remind you of? Anyone? Isn't this frequently asked questions, right? If the car is dead, then if you go to the help desk, frequently asked question, what should I do? So the system, the web page will tell you, if the car is dead, please check your fuel tank. I think some of you may realize that I've seen this in troubleshooting my computer, troubleshooting the program, right? So the other day, I think yes, Sun Yun Xia, yeah, correct. Phone is one thing, but phone is also you have a voice. This time I'm looking at the text base. So you can see it's actually quietly been used. So you don't realize that it's a form of expert system, but of course that is actually very dead in the sense that it's just a series of notes for you to read, right? Because as I said the other day, I was having problems in my PC, and then yes, my buttons on top of, I think I told you before, buttons on my top of my Gmail, the one that said delete, label it, and move it to a different bin, is invisible, cannot see. So I don't know what's happened to it, and then I was so worried because I can also then I cannot even I cannot even pop open my Google applications, because normally what I do is that I put all my timetable onto my Google Calendar, so that when I open it, I know today I have a lecture and this is a Google link, so it's very convenient for me. And that one, for some reason I can't open it. So I was a bit worried, because if I can't open it, then I have 90 students waiting for me, and I'll be struggling to find the link and to open it. So that is something that I went online and checked. So this is what I found. Then the system will tell me, please check. Have you checked this? Have you emptied your, what I call that? Your history, your history. Can you maybe then they say, if all this fails, like here, all this fails, please reinstall Google Chrome. Right? So these are the things so it's the strategy helping you to do that. So I can see it's quietly being used. I think without us noticing it, because it's a form of expert system, right? Because of what that one is a bit, I will call it dead in the sense, it's not exciting, right? That's why exciting, because why? You have to read, so you never think it's a sort of expert system, so you have to read all these things. But this is what happens. Now, if you do this using put in a avatar, right? Something that's a artificial being on the system can talk to you, can smile at you, right? Come back to you, right? On your PC screen as a as a live as a live person. So we see that this is something also very useful as a strategy. Now, what is heuristic? Heuristic is something like common sense, right? Tell you that now in this case you find that there's a liquid on the floor, so you're a bit careful. What is that liquid? So they ask you to check. Now your sensor tells you the pH is less than 6, and there's a strong smell of vinegar, right? Coming from that liquid. So the system will tell you this spill material is probably acetic acid, right? So this is so you can see there are 5 different ways you can apply expert system to help us in our daily lives. So I think that's where we stop in the main players in the development team. There are the 5 members. There is the domain expert, right? So now, why do we call it domain expert? Because as you see, as I also pointed out in the previous few pages, that we can't be expert in everything we do. So that's why you cannot be a good accountant, you cannot be a good electrical engineer, you cannot be a good mechatronics engineer, or you cannot be a dancer, right? A dancer, musician, a guitar player, or a drum player. I always wanted to be I like to play the drums. I think it's cool. It's quite nice also to play the drum, because I have not started that learning that yet. So if I do that, have to talk to a domain expert. So it's a very specialized field, right? And also we also understood that how do we get ourselves to be called an expert? So we should have some deep knowledge in that field, in that area. The next team member will be your knowledge engineer. So knowledge engineer will be more of a, I think, architect. If you use a equivalent term, architect in the programming world. So this person will then be able to design for you the what goes into the whole system. And then later on we see what the person is supposed to do in for this knowledge engineer. There's also, of course, the programmer, because the expert system and many of these artificial intelligence systems are actually software based. I think that's the only way we actually can capture the intelligence and then use it in some way to turn on certain sensors, to turn on certain actuators, to turn on certain valves, to turn on certain devices. So that is so this is a brain. The brain actually is a software based. There's fourth team will be your manager. So this is I call him her, the slave driver. So this person is the one who always come breathing down your neck, tell you, have you made this? Where are you now? What's the deadline? So I think some of you can also see that in your, not all, some of your FYP supervisors who come bugging you all the time, asking you what's the status, have you done this, have you done that? I think the end of the day, because the whole project is under the management of this project manager. So the project manager, I think later on you see that he actually has an answer to a few people, especially the customers or your end users. Because end user will be interested to know, when can I get my product? When can I get my system, my expert system, so I can use it, right? So actually, you need a system to make more money. I'm also reminded this morning, just to share with you, this morning there's this, I saw in the papers that this not company, is a young person in Penang who actually use a 5G network to actually allow him to harvest, not to harvest, to detect once the fruit has fallen down. It seems that I think some of you may be better this than me. Know that once the durian falls onto the ground, if you eat the durian within the less than 2 hours, it seems that it will have a tingling sensation. Your tongue will feel numb. Anyone tried that yet? In Penang. So this person actually developed a system to actually help him to detect, right? So his his intelligence system is to detect once the durian falls, so that he'll quickly run to the proper area and collect the durian, and then straight away open to his customers. So what does that mean? It means that if I have such a system, I can fetch a higher price for my durian. So it will not be just another durian, right? Because you sell durians, I sell durians, but my durian is actually freshly dropped from the tree. That is yeah, correct. Me too. Because I don't own a durian farm. Any one of you own a durian farm? Can share the fresh durians with all of us? I think only in Penang. So know how it works. So what happens was that interesting because he actually put a fish net underneath the tree, right? And I think there will be some sensors there to detect once the durian falls. Once the durian falls, it will move the net. So once you move the net, then the sensor will transmit the signal, I think through his 5G network, back to the base station, and then the person monitoring the thing will know at this location a fresh durian has fallen. So that one to me sounds interesting, and I think it's also a very unique way of actually applying technology to help us in agriculture. There's another, I think some of us believe that there's a big field in combining AI into agriculture, what they call it, smart agriculture. So this is something that we can look at, apply it in the near future. Maybe some of you may be working on that too. So that is all. I'm telling you why the end user is so interested, right, to have the product as soon as possible. So then you have this, so the customer, your end user will chase after who? Will chase after your project manager, right? So the end user will chase after project manager, and project manager will chase after who? Chase the rest of the team. The project manager will not catch out the domain expert, right? Because he's such an expert, he's a consultant to tell the team what to do. So this project manager will chase after the programmer, or maybe the launch engineer who chase after the. So these three guys will be affected by this demand of your end user. So the other thing is that the success of your expert system entirely depends on how well the team members work together. So again, this is something you have to learn to work together as a team, right? So whether your project is able to meet the deadline and what else? Deadline and your customer requirements. The technical requirements of the project itself entirely depends on this, how well you work together. So that's why we actually have this embedded into many of your course, right? I think starting from year 3, where the capstone project, I will call it, forces you to work together as a team. And I think for some of you, it may have been a very pleasant experience, but some of you may not be. So, but again, this is something you have to learn, because when you start to work, you have to work with different people. So how well you work with different people will also result in how well whether you are successful or not in your career. And I think so. I think we also talked about this early on. I think during the various tutorials, right? We talked about this before. We talked about intelligence, and this is one of them, which is your emotional intelligence. EQ, emotional quotient, which is a measurement of your emotional ability to work with other people, relate to other people, so that they don't feel threatened, they can still smile at you, work with you. So this is actually very important. So that's why we have actually embedded into the course itself. We ask you to work together as a team. So then you learn, right? How do you handle such people? And I think some of you may also encounter very difficult cases whereby your team member may not be very cooperative. So again, this is something you have to learn to how to make a person who is not cooperative and to be cooperative, because you, end of the day, you need to deliver the project or product to the customer. So this is the high level schematic. I think that's where we stop. High level level diagram or figure of the expert system, the team itself. Okay, now let's start with the domain expert. Now, who is a domain expert? The domain expert is knowledgeable, right? So we said before many times, we cannot simply call you a domain expert unless you are knowledgeable and so skilled, right? So you can see there are two things here. This is more on theory. You have a knowledge, and then you are able to do something using that knowledge. So so back to our example of the durian, the 5G durian plantation in Penang. The somewhere along the way, right? So the programmer of the intelligence system will have to talk to the durian planter. So we tell what should I do? So this is so something like consultant to help advise the expert system team what to do. So this one is so you have a knowledge, theory, and then you also expertise to do certain things, and then you're able to solve certain things in that specific area or domain. That's what it means. So this person has the greatest expertise in a given domain. So now again, look at the sentence. This person has the greatest expertise in a given domain. So what challenges do you see? How do I appoint? How do I invite so and so to be my domain expert? So think back about your FYP. If you're doing FYP, you need to you also need to contact, right? The domain expert if you can. Now, in the absence of this, what can I do? Because in your FYP, not all of you have the luxury of talking to an expert, real life person. What do you do? What can I do if I don't have my physical domain? What can I do? Anyone want to try? No one want to try. Okay. So I think that the one it will be, you have to go back to your literature review, prior work. So that reading those papers will tell you how can you solve the problem, right? So this expertise, in the human, this expert has to be captured, so has to be translated, has to be translated, change, right? That expertise or knowledge has to be captured and then somehow used in your expert system. So you need to capture that information so that then your expert system then become another expert, right? Any comments, questions? Okay, no. So therefore, the expert must be capable, must be able to communicate her knowledge, willing to participate in the expert system development and commit a substantial amount of time to the project. And some experts, I would say, sorry for the use of the word again, expert. Some experts believe that, some experts in the expert system believe that such a domain expert is perhaps the most important player in the expert system development team. Let us try to analyze these two sentences here. First question is, your expert must be willing to work with you, right? Because the expert must be able to communicate, willing to participate in the expert system development. So if you get someone who is reluctant to help you, he or she will keep his mouth shut, right? And will not communicate, tell you, share his knowledge. And then because you see it, you also have to, sharing of such knowledge, you also need time. So the person must be willing to spend some time. So in the real world, such experts are not, such expertise is not given for free. So what we normally do is that we have to maybe pay them a certain amount of money. That's why sometimes we call them consultants, because they will help you. So of course, if you pay them money, of course they'll be more willing to to talk to you. If you don't give me money, um, um, they may not be so willing. They will give all kinds of excuses. I'm not free, or whatever reason. I have other things to do. So normally, what we do is that because once you pay them a certain amount of money, so they have to be committed. Otherwise, I won't pay you, right? So again, so these are the things. So you need to talk to the person, and of course, back to here again. You must be able to communicate. If you can, I think communication, as some of you realize, is a two-way process. Is you don't blame the other person if you cannot get your correct answers, right? So you must be able to communicate well, ask the right questions. Because if you ask, one of my friends told me, if you don't ask the right question, you cannot find the answer. So the right question will actually lead to the right answer. So again, you need to talk to the right person with the right questions. So first two parts here: right person and the uh, right questions. So, and then you can see already, you can sense it's not so simple. So how do you get the right person first of all, and then ask the right question? So again, this time needs effort from your side to identify. So again, some believe that if you have that's why it's important to get to meet different people. Those people can help you. I need a 5G system developer to help my durian plantation. Who can I see? If you don't have a wide network of friends or colleagues, people you know, so this one you will have difficulty. So in a way, the older you are, the more time you spend in the industry will expand your network. So again, this is something you have to think about. So right. So I think I also hinted I think later we'll discuss this again. That is the other part is how do you identify the best expert to help me? Right, we'll come back to that question again later on. But of course, in case I forget, please someone remind me again. How do I find the best person, expert to help me in my project, in my expert system? We'll come back to that later on. I think we'll explain the next few slides. The next person, next important person, actually, I differ. I think I differ in the sense that I don't agree that the domain expert is the most important person. I think all of the players here are actually important, equally important, right? You cannot work uh, without one of them. Right? So I think in that sense, everyone is important in this team. So who's a knowledge engineer? The knowledge engineer, I think it can go by different names. I think in the conventional software development team, I will call this architect, the software architect. So of course, in this example, in this particular case of expert system, we are talking about the label is a knowledge engineer. Now, the knowledge engineer is someone who is capable of designing, building, and testing an expert system. So I can see that's why I call him her architect, right? So this one is I think in a way the next person below this project manager, right? So this person will able to design design the actual system, the building blocks, what needs to be done, right? Before the actual programmer starts to look at start to develop each of the components. So and for FIP, I think actually your FIP, what is it? Your FIP, I would say you actually everything except the domain expert, right? Because your supervisor is not the project manager. So actually you should be driving yourself. The supervisor is only there to check on you once in a while, and also at the same time give you some advice on you get stuck in your problem, in your development, in your work of your FIP. So this knowledge engineer will be capable of designing, building, and testing. So he or she will design, he or she will build. I think the building will be with the help from the programmer, right? So this one, and then testing as well. So you need to also testing itself. Although this sounds very simple, you have to also be careful. Spend some time to actually understand how you intend to test your system. Now, for those of you who have I would call it more experience in software programming. You find that you to identify the test cases is also important, because if you miss some of those test cases, your system cannot check, and then your system will crash. So if you want your system not to crash, you have to think carefully. What are the things you should look out for? What are the things your system should test? And I think we have completed. Have you completed the lab number one? I think if I'm not mistaken, all of you may have completed your lab number one. So we are going to lab number two. So lab number one, if you remember, we have to do a small program called My Classify to label the numbers given to you, which actually lies between the range of 0 and 1. Whether it is less than 0.5, you label it low. More than 0.5, you label it high. And then, of course, exactly equals to 0.5 becomes middle. So now, what happens if the user, for whatever reason, right, put in a value of minus 0.5 or plus 1.7? So if you do not if you do not check such a thing, your system will probably crash, right? It cannot handle such thing because it doesn't know. So in a way, your system itself is as smart as the programmer. So you have to be able to test for such things. Now, what else does the knowledge engineer do? He or she will interview the domain expert, right? So this is the person who will talk to the domain expert and find out how a particular problem is solved, right? So again, as I said just now, in your FYP, you're not able to talk to the domain expert. What else can you do? What you do is that you look at the papers published before. That's why we call it prior work, literature review, how that same problem has been solved in the past. So in this case, you talk to the domain expert, right? So in this case, normally in such cases, in the real world, the user, the customer, can also be your domain expert, because he or she, if he or she wants the system, he or she will know have some knowledge about how the problem can be solved, or exactly maybe not that solution, but again tell you that what is the problem he or she is trying to solve, and that's why he needs your help. So that knowledge engineer will then establishes what reasoning methods the expert system uses to handle facts and rules, and decides how to represent them in the expert system. So in this case, you can see here, the knowledge engineer will be the architect who decide what methods do I use. Do I use deep learning? Do I use fuzzy logic? Do I use artificial B? Do I use particle swarm in the case of, or do I use support vector machines? There's so many tools you can use. I call them tools. So again, if I want to build a house, do I use a saw? Do I use a screwdriver? Do I use a hammer? Right. So you have to decide what's the best tool to use, or you can use all of them. Right. So this will be you decide what reasoning methods you use. Right. Now, then these methods are used to do what? To handle the facts, the information, the data. So again, back to our example this morning about the durian grower or planter in Penang. What are you looking for? I'm trying to look for the when the fruit when the fruit is ripe and drops down to the ground. I think in the old days, I think if you live near enough to a durian tree, you can hear the fruit dropping onto the ground, especially in the morning when the here. So question is, how do you what are the facts, what are the information data you need to provide for the expert system to decide when the durian has fallen? So this is what you mean by facts, that raw data, what's the input. So this one also decide. Now, if you come back to engineering, this will decide what sensors do I use. The sensors will to use, and then at the same time, what's the output of the sensor? So in this case, the sensor will trigger. If the thing drops, it can be a sound, it can be a like microphone, right? Microphone is also a sensor. It will detect the sound, right? If the thing drops to the ground, it can do it. Now, somewhere here also not highlighted, which is also the cost. So if you use sensor A, sensor B, sensor A may be on vibration. It means that your net, when they drop to the net, doesn't hit the ground, so it won't break open, and also keep the fruit dry. So if the fruit drops to the net itself, it will trigger, it will move the net, right? So you have a sensor that detects movement, or you can put in as I said, a sound sensor. I mean, you let the durian drop to the ground, and then you measure any of the sounds. Now, if you use the movement sensor versus the sound sensor, which one is more expensive? So at the end of the day, you also need to be careful, because if your system is too expensive, your customer obviously will not like it, right? So you need to be careful with the costing as well. So that's why I think FIP also, FIP 1 also, or no, Capstone, we ask you to look at the costing of your system so that it will not be too expensive. And then once you identify the facts, they also need to look at the rules. This is something we want you to look at in your assignment. How do you design the rules, right? And then from the rules, again, same thing, rubbish in, rubbish out. If you cannot decide the right rules, your system also cannot be accurate. So if the system is not accurate, your customer may not pay you, right? Your system is not good enough, I won't pay you, right? So there's something you need to be careful. And then, of course, once you've done that, you have to then figure out how do you connect all this together into your expert system. So then the knowledge engineer, this other role will be chooses some development software, or in the older days, they call it expert system shell, which is basically what software do I use to implement that? Do I use this MATLAB, or do I use C++, or do I use Python? Example. So nowadays, I think if you do programming, AI is either MATLAB, which is very fast, or Python, which is also quite fast to learn, also quite useful, right? And you can actually implement it. And then, of course, also the actual MATLAB has come in two parts. One is the actual language itself, and also the shell, the user interface, to help you to create that program. So look at all those things to actually encode, to capture the information, though. So you can clearly see that you use this software is to capture your information of the expert, and then is now duplicated, repeated. Another version of it is sitting now in your machine, right? And finally, the knowledge engineer is also responsible for testing, revising, and integrating the expert system into the workplace, into the real world. So in a way, the knowledge engineer is the chief architect. Also, it's also important person in this system development of the expert system. Now, next person will be the programmer. Now, the programmer is the person responsible for the actual programming, and then describing the domain knowledge in terms that the computer can understand. So he or she will code the knowledge extracted from the domain expert into something that the computer can understand, can also do something useful. Now, the programmer needs to have skills in symbolic programming in such AI languages, such as these are the old languages. I think you've never heard of them. I think some of you pointed out Lisp is one of the languages in AI. Prolog, OPS 5, I don't know what that is, because it's, I think, outdated now, no more used. So nowadays it's actually, I think you heard of it using Python. It's one of the, or C++ is also another very good program language. And also some experience in the application of different types of expert system shells. So how can you use this program language to develop AI programs? So what I call expert system shells. Excuse me. In addition, you also have programmers who also know some of the programming languages. These are some of the older programming languages. So Fortran, C, or nowadays is C++, Java also, I think, is outdated already, right? But the hottest one will be Python, so that you can actually uh, use it on different applications. Again, you have to be careful again. What is my device that my program will run? What's the device that my expert system will run? Is it running on a handphone, or is it running on which is an Android phone, or is it the Apple what you call Apple chip, Apple processor, or is it on the standard desktop PC? So that one also has to play a part, important part for you to understand, right? So again, if you build a system, you expect it to run on the desktop, but end of the day, the customer say, I want nowadays because a handphone is more useful for me. Example, go back to our durian again, durian the grower in Penang, right? So imagine if I had to carry a big PC with me to find out where's my durian that has fallen versus my handphone. Which one do you think you prefer? Of course, handphone, right, is so much smaller, portable. I only need to know where's the location. So if you program expert system for handphone versus a desktop, there are also some differences, which you have to be careful. Again, this is something you also need to. Uh, this one, I think this is something also missing. This one actually. I think doesn't talk about the end user, right? It doesn't talk about what the user wants. So this one I think is also not that complete. I would say complete because you also need to know he's the person who designed the whole system. So you need to also know who is your what your customer wants, right? I think later on you see what I mean by that. So good. Anyone have any questions, comments, right? So the project manager. Now the next one is the project manager. The project manager is the leader of the expert system, of the expert system development team. So, of course, you cannot be the project manager at the start, right? So after working for a few years, you find that you'll be promoted to become the project manager. Then you know that what is supposed to do, right? And also the person is responsible. Now you're more of a manager now, managerial position to keep track of the project, whether it's behind schedule, and if your team members need extra domain expert, you need to also find out who can the team talk to, and you also allow maybe more programmers. If you find that the programming is actually behind schedule, you need to also try to invite or get a few more programmers to join. But of course, you have to be careful again. Why? Because of the costing issue. So he or she, this project manager, will also make sure that all the agreed deliverables, what you're supposed to deliver and when you're supposed to deliver, are met. And then he or she, this person will also interact with the domain expert, will also interact with the knowledge engineer, programmer, and user. So this person here is actually, I can clearly see, is actually have a important role to play. He's a leader of the team. Talk to everyone, right? Ranging from expert, domain expert, knowledge engineer, programmer, and user. So again, can clearly see, very busy person. What else? You also need to have good communication skills. You also need to have able to keep track. Means you need to be able to now expertise as a project manager. We also teach you, right? We have called project management. How to keep what tools you can use. FIP. So FIP is the first time you're coming. You're actually managing. It's quite simple because there's only one person. You're managing your own project. Imagine you're managing a few team members. In this case, your domain expert, knowledge engineer, programmer or programmers, and also end user. So again, this one from experience will tell you that if you talk to a different end user, he or she may give you different, sometimes conflicting requirements. Right? This person said, I want to have a think of a good example. Maybe for example, I can't think of a good example. Sorry about that. So, but I think if you have if you talk to the company, if you don't talk to the right person, for example, you talk to the CEO and you talk to the actual person who wants to use the system in the company, right? I mean, for example, if the company, I mean, good example. Go back to our durian again, right? I think in this news report that I read, this farm in Penang, the owner is a man. Then his son is the one I think actually is also helping the father to run the business of this uh, durian plantation. Now, who do I talk to? Do I talk to the father or talk to the son? Right? I'm not saying who should you talk to, but you have to be careful that you talk to the right person, because sometimes the father might see things differently and the son might see things differently, and you talk to both of them, and then who do I follow? Do I follow the father or do I follow the son? Sometimes you end up with different system. Right? So again, it's very important. I think you can sense what I'm trying to drive at. Communication is very important, because unless you're able to get to the right person who will sign off the project, that means that I agree the project is actually successfully developed, I will now pay you, right? If you don't talk to the right person, this person said the son said I want it on a handphone. The father said no, I don't like handphones. I want it on my PC. Then another one, the daughter said I want it on my notebook. What the notepad. So because the notepad the right end user. Of course, just the user is a person who uses now your expert system when it is successfully developed. The user must not only be confident in the expert system performance, but also feel comfortable using it. Very important. So the user experience is very important. The user interface is very important. Find it difficult, not comfortable using it, I won't use it. Then what you've done actually money, right? So of course, worst case is I will refuse to pay, right? So I don't think your system is good. Now, for those of you actually working on the industry sponsored projects, take note of this. So every day your developed prototype must be able to satisfy the sponsor, your industry sponsor. Otherwise, they will say the system not good enough. So therefore, the design of the user interface of the expert system is also important or vital for the project success. Because if you cannot design a good user interface where the user feels comfortable using it, right? The end user's contribution here can be very crucial. So therefore, you need to be able to understand what he or she, the end user, wants. Because if you cannot provide that useful user interface, the end user may not be happy or may not be comfortable using your system. Right? So far so good. Chung-Yi, I think the line dropped again. This one. As I said the other day, I think let's look at the communications. So if you talk to your user, even your project, so it's how your customer explain to you, or rather what you understood, what the customer wanted, right? So again, as I pointed out before a few times, it's all about communication. So to the best of your ability, you understood what your customer wants. So I call it importance of communications. This is how your customer explain to you. Then when the project leader, which is maybe your knowledge engineer, right? The project leader, which is a project manager, right? So this is what the customer explained, right? In the best of his or her ability. But what the project manager understood was something like this. So you can see it's a bit simpler than this, what the customer explained. Now, then when it comes down to the knowledge engineer has to design the overall system, right? So again, you can see here, there's also the possibility that the knowledge engineer design your system look like this, right? So Then you have another player, right? You have your programmer. Now, how to write the program? I wrote it. So this is a representation of the program understood and what he actually set up to do to design this, write the system or develop the system. And then this is another part. This is actually the marketing side, the sales side. Of course, I know in the last company you wanted as much as possible to have a high cost. You get get a lot of profit. So this is how the customer end up paying. The company will say, I will now charge you 1 million ringgit for your system that you wanted. So this is what the customer wanted. What the customer was billed, right? A very expensive looking system. So this is what the customer really needed. So you can see that in the process, right? If you're not well, what your customer wanted and what you actually develop and design and produce is completely different, right? So you can see this is to share with you a light way of looking at the humorous way of looking at communications. Why it's so important, especially in a large project when you have to talk to various parties. Now, what is the structure of your rule-based expert system? So in the early 70s, this two-person, Neville and Simon from this CMU, which is the Carnegie Mellon University, proposed a production system model. That is your expert system, which is the foundation of your modern rule-based expert systems. So nowadays, I think we still follow that, but of course, I'm not sure whether we still need to have this production system model of those 70s. Well, 70s is about 50 years ago, so it's a long time. But of course, the concepts in this rule-based expert system still valid. Now, this production model is based on the idea that humans solve problems by applying their knowledge, right? So the actually found out that how you want to find out how do humans solve problems by applying the knowledge. So this is when you apply this knowledge, they call it Neville and Simon call it production rules. So these are your need to also create such production rules to a given problem represented by a problem specific information. So to solve a problem, you must have that such problem specific information. Now, how are the production rules, which is the knowledge, how are they stored? The production rules are stored in the what we call the long-term memory. Your long-term memory and your short-term memory. The long-term memory is stored in the stores the production rules, the rules where if you do this, you will see this, you do this. Those are what we call long-term memory, and those are actually the production rules. Now the real-time information or data or facts will change, and this is actually stored in the short-term memory. Okay, I think we will stop here for a short break. Right, and we'll come back. We'll continue with the structure of the rule base, and then we talk about the production system model. Is it okay? So we take a 5-minute break. We come back. Okay. Of course, before I go off, any comments or questions from you before we go off for a short break? No. Okay. We take a short break and come back. 5 minutes time. Thank you. Sorry, I think let's start again. The Can you hear me now? I can see because I turn off the mic. Sorry. So the structure of your rule-based expert system has two main parts. Now, what are those two main parts? The two parts will be your long-term memory. Now, what does this long-term memory do? The long-term memory basically is to store your production rules. So, what are these production rules? So, production rules are your basically the information or the knowledge to solve a problem, right? So these production rules will help you to store, will actually help you to solve your problems by applying the knowledge to these production rules. The other important component of your rule-based expert system will be your short-term memory. Now, what does the short-term memory do? It actually stores your problem-specific information or facts. So this will be used to store your problem-specific information facts. Now, how do these come together? These come together with your, can see here, this is a high-level figure of your production system using this Neville and Simon's production system model for the rule-based expert system. On the left-hand side here will be your production rules, which is actually stored in the form of a long-term memory. On the right-hand side here will then be your short-term memory consisting of just the facts or information. This will be the facts that you supply to your production or expert system, production system or production system, which is your rule-based expert system. So this one will use that. So this one, so then this is your actual reasoning system. How you combine the rules and then the facts, and then give you something that you can use, which is your conclusion. So in this case, as I said before, you can use it for 5 different types of application, which is your heuristic, recommendation, right, directive, and so on and so forth. So if you go further, more detailed description system model, you can see that now we have what we call the long-term memory is also known as your knowledge base. And then your short-term memory is now called your database or your facts, right? The information for that particular problem you're trying to solve using this knowledge base of your long memory. So the knowledge base, you can see here, basically consisted of just your set of rules, which is based on your if-then set of rules structure, which is your antecedent and your consequent, right? Antecedent and your consequent. So these are the rules here as you form them inside your knowledge base. So then you have your inference engine, and then this one actually you can see here. This is your so-called high level will be reasoning, but you go further down, you can find that it actually consisted of a few things. First of all, is your inference engine, where you combine the information from your database, the actual data for the problem you're trying to solve. Are you solving for the weather forecast? Are you solving for the what you call a tourist, or are you solving for the diagnosis for your car? If your car cannot start, right? Expert system to help your car move. So this will be, of course, different for different applications or different problems you're trying to solve. So the facts will be different, and then the rules will also be different. So this will be different, but the structure will be the same. So when you combine those two, and then it will tell you, you have something called the explanation facilities to help you to explain the output from this inference engine based on your rules and your data or your facts. Now, before it goes to show it to your user or your end user, you need to so-called make it beautiful, right? So that something that the user may not be a technical person. So the user must able to show the information in the right form so that the user will be happy that your system is trying to tell you. So this is also very important. So as I said, so you need to keep the end user happy. So this is your user interface to keep the end user happy. So this is basically the basic structure of your rule-based expert system. Now let's explain what is the left what each of them supposed to do. The left hand side, which is the knowledge base or your long term memory, contains the domain knowledge now, right? Domain knowledge useful for the problem solving. So in such a rule based expert system, the knowledge is represented as a sort of rules. Now, again, I think in the first part we actually explain why, because that's how we capture the information, the knowledge from the expert, from the domain expert. Each rule specifies a relation, recommendation, directive, strategy, or heuristic. Right? So it will tell you, are you telling me the relationship between the two components, or are you recommending to me that I should pick an umbrella because your conclusion is that it will probably be raining because based on your information that you have. Directive, strategy, or heuristic, and has the basic the same structure, which is your if condition, if which is your or condition, and your then, which is one or action. Yeah. So it's very simple. Main thing was also remember the expert system has basically this structure, if then structure. Now, when the if condition part, right, or the antecedent part of rule is satisfied, this part is satisfied, the rule is then said to have fired, right? Fire, it's like in the not RP, this is fire as in a gun. You this part will be activated or fired, and then as a result, the action part, which is the then part, will be executed. The database, which is your here, the database containing the facts or your short-term memory, includes a set of facts used to match. So this database is used, the facts inside this database is used to match against the if parts of the rules stored in your knowledge base or your long-term memory. So the database will include, right, the facts. This is used to match, which is used to combine against the if condition parts of the rules stored in the knowledge base. So you can see all this here. You need two of these to work together. So you have your rules, which actually you design your rules, but then you also need to use the rules against the current facts that you have, right? So you have to active. That's how you run your expert system. Now let's look at each of these three other components. Inference engine. The inference engine will carry out the reasoning, right? Will explain or try to reason out based on the rules and based on the facts, whereby the expert system reaches a solution. So this one will generate a solution, generate an answer based on the rules and which rules fire and which are what are the facts you have, right? With the facts provided in the database. So it links the rules in your knowledge base with the facts in your database. Links them together. This is the role of your inference engine. And you come to the next part, which is your explanation facility. So after you have able to generate an answer, conclusion from your inference engine, then the information is passed to your explanation facilities. Now, the function of your explanation facilities is to enable the user to ask the expert system how the particular conclusion is reached and why a specific fact is needed. So this will explain to you how the system arrived at the conclusion. Very important, an expert system must be able to explain its reasoning and justify its advice and analysis or conclusion. Two parts here. It must be able to explain, right, why you tell me to bring an umbrella, right, and then also show proof that this was based on what facts, right? So this one, and then justifies is whether it's advice, directive, heuristic, recommendation, or conclusion, right? So this is one of the major differences of your expert system as compared to your neural network space. So then the next part, the final part, which is here. This one is actually to calculate or compute what is your conclusion based on the facts and based on the rules that fire. So it gives you this. And this one actually is to explain how you actually arrive at the answer. Why do you tell me to check the car battery? Why do you ask me to check the petrol tank? Based on what facts? What are the rules that fire? And then this part actually is will be the then you have to explain how you get the answer. The last part here is actually user interface. Now, what does the user interface is a means of communication between the way you actually relay the information, right? Show the information, show the results in the appropriate way. So we need to be able to show the answer in the appropriate way to the user of your expert system. So this is also this one will probably need I think we call it a human user interface expert to actually design the appropriate user interface, right? So that the user can understand. But don't forget that if you're designing a general system, expert system that can be used for different types of application, you also need to be careful to actually design your appropriate user interface that anybody can use. So a good example would be, for example, the MySejahtera. So you have to figure out because the MySejahtera system actually has a few million users, so they can come in all shapes and sizes. So you need to be careful that all these different users can understand what your system is telling them to do, right? For example, if your system tells you to bring umbrella, make sure you have something to tell them to bring umbrella, or ask them to check the car battery or the petrol tank. So something like that. So you have to be appropriate user interface to communicate the answers to the communicate to the users in the right way so that they can understand what you're trying to tell them. So then now is this one expanding. Now this one is a simpler version. Now this is expanding the complete now. So you can see here, once you expand, the system itself can see a bit different now. A few external things, a few additional things. That is the first of all, the external database, right, is also added inside now. So also external program, which is used to actually for this for you to develop this inference engine. Now, other than that, the user interface here is actually now expanded into two parts. First part is the same user interface, which is to communicate to the user. Now, in addition to that, you also need to have a developer interface for the programmer, for the expert to communicate, to modify the system, to change the system, to develop the system. So this is a separate user interface because you can't have the same interface for the user and the developer. So this will be more technical. This to these two experts, these two teams to actually assess the explanation facilities, also the inference engine. Now, what are the important characteristics of an expert system? The expert system is built to perform at a human expert level in a narrow, specialized domain. Right. So the key thing is, as I said many times before, it's actually very narrow. It's a narrow and also specialized domain to solve a particular problem in that domain, in that area. Therefore, the most important characteristic of the expert system, it is high quality performance. High quality. Okay. So I think explain further here. So you have two things here. Now, if the speed, right, if your system is very fast in solving a problem, right, no matter how fast your system can solve a problem, the user, your end user, your customer will not be satisfied if the result is not correct or it's wrong. So you speed is one thing. Of course, other than that, it's also your accuracy of the system. On the other hand, the speed of reaching a solution is also very important because even the most accurate decision, that means your answer is 100% accurate or 99.9, or the diagnosis may not be useful if it is too late to apply. For instance, in an emergency or when a patient dies or a nuclear plant explodes. So again, you have to be, so again, it's not just one, you have to match the two. So this is something we also have discussed in the earlier lecture and the other lecture. We talk about the if you use a brute force method to actually find the shortest path, right, for your traveling salesman problem, or even the shortest path between point A and point E, for example. You can get a good answer, but it takes 10 years to process. To get the answer, it's too late. So it's always a challenge to actually have an accurate answer and also a fast answer. So you can't have either one of them alone. But you can't have a fast answer and the answer is actually not accurate, right? Only 10% accuracy. Or you can have a good answer, 99.9% accurate, but it takes you 10 years to process, to compute the answer. So this is an example. So again, if you're using it for medical, right, helping the diagnose, tell the patient what's wrong with him or her. So if it takes a long time to give you an answer, so no point, but by then the patient may have died. Or if you tell me, if I'm using it to monitor, to manage a nuclear plant, power plant, right? So if the system detecting, if the system is detecting any abnormal conditions, if it takes a long time to process, by then the power plant may have exploded. So this is actually, you have to, so the main two things will be speed as well as accuracy. So these are the two main things you have to worry about in any system, actually, for that matter. So therefore, the expert system apply what we call heuristics to guide the reasoning and thus reduce the search area for a solution. Again, we come back to our familiar term, heuristics. So because if you use back the old, the traditional way, if you don't use heuristics, you find that maybe A is taking too long or B is not accurate. It's fast but not accurate. So you have to apply heuristics to help you to do that, to reduce the search area so that you don't search the other area, so you can come up with a reasonable, good solution and also quite fast. A unique feature, this is something I think I explained before. So this is very unique to the expert system, is this explanation capability. Unlike, for example, your deep learning or your neural networks, right? It's one of those, this method actually neural networks doesn't tell you how we arrive at the answer, it tells you the answer. So imagine if you're using the same system to tell a patient whether he or she has a coronavirus, the flu. It simply tells you, but you must show proof to the person that I arrived at this conclusion based on this. So in this case, will be your COVID-19 test. Based on the test, this is no certain things will activate, and so therefore, the system tells you have this coronavirus, COVID-19 disease, flu. So with this explanation capability, it then allows the expert system to review, to tell it, to explain its own reasoning and explain its decision, right? Why do you come up with this conclusion, and then explain how you arrive at this conclusion. So the expert system employ what we call symbolic reasoning when solving a problem, right? And then symbols are used. What is this symbolic reasoning? So symbols are used now to reason for these expert systems. So symbols are used to represent the different types of knowledge, such as the facts, the concepts, or the rules. And the rules. Can expert system make mistakes, right? So I think this is again something we talk about in the first lecture, the introduction to AI. Humans make mistakes, so can expert system also make mistakes? So the answer is, even a brilliant expert, right, is only a human, right, and thus can make mistakes. So it's talk about humans, human expert. So you ask the human expert, of course, the human expert, the smartest of them, can also make mistakes because it's only human. But of course, having said that, is also you cannot be making mistakes too often. If you make mistakes too often, then you lose the trust that you are actually an expert, right? So all the time you make mistakes, so you cannot be an expert. So therefore, this suggests that an expert system built to perform at a human expert level also should be allowed to make mistakes, right? So we still trust the experts, even we recognize that their judgments are sometimes wrong, right? We still say so and so is an expert, even though sometimes their answer can be wrong, right? So likewise, at least in most cases, we can rely on solutions provided by expert systems, but mistakes are possible, and we should be aware of this. So again, you can accept the recommendations or the answers from your expert system, from your AI system, from your intelligence system. But at the same time, you should be aware that it can also be wrong. So that's why we need to go back to this explanation. You need to find out how did it arrive at the answer. Now, you as a maybe expert, human expert, you check back based on these facts, based on these rules, it should only arrive at this answer. But your expert system tells you a different answer. So how can that be possible? So that's why you can check back how the system arrived at the answer, and then you use your own reasoning, right, to review, to check back how they arrived. Was it correct to arrive at this answer? Was it correct to tell you that it will probably rain today, therefore they ask you to take an umbrella, or your car cannot start because your battery is flat, or the fuel tank is empty. So that's why it helps you to review. Now, if your review is not the same, then you find that maybe I cannot trust this system anymore, because it is possible it is make a mistake in this case. So in expert systems, the knowledge is separated from its processing. That's one of those things. The knowledge itself is separated from its processing. The knowledge, and then there's also the data, the facts itself, so separated, and then you use this engine to actually process the two parts. So it's separated from its processing, and the knowledge space and inference engine are split up as we've shown just now. Now, a conventional program is a mixture of knowledge and the control structure to process this knowledge. This mixing, this is the normal way of programming. This mixing leads to difficulties in understanding and reviewing the program code. Right, so if you go back to your normal programmer or C++, in a normal C++ programming class, you have to write a code to add two numbers together. So how this is actually mixed up. The control structure is mixed up with the actual information. So it's not easy for you to understand how your program runs. So this mixing leads to difficulties in understanding and viewing the program code, or as any change in the code affects both the knowledge and its processing. This is the conventional way of programming. Expert system, no. Expert systems, the processing and the knowledge base are separated. Right? The processing, the inference engine, and the knowledge base are separated. Now, when an expert shell is used, when your expert shell is used, the knowledge engineer or an expert simply enters the rules in the knowledge base. So when you use this knowledge expert system shell to help you build expert systems, the rules and the rules are entered separately, so you don't touch the inference engine, the inference part. Right. So if you want to change the system to handle different applications, you change the rules over here. So the processing is actually separated, independent of this. So each rule, if you add a rule, each rule adds some new knowledge or makes the expert system smarter, because now you have more rules. So again, it's a very simple way of explaining it, in the sense that when you have more rules, the expert system now becomes smarter because it can now handle more different different conditions. Different conditions, because you enter more rules to cater for these new conditions. So therefore, it is now smarter. It knows that it also can go back to the earlier one. Talks about the rule will be based on just maybe your car cannot start. Check the battery. So if the car battery is flat and your car cannot start, so therefore change the battery. But now you have another rule, which is a new rule that says that check the fuel tank. So you have more rules so that the system now is smarter. So it knows that you also need to check the fuel tank. So that's why if you add the rules, it will make it smarter. So the more rules you have, the smarter it is. But of course, you need to be careful because that's a trade-off, right? It's a trade-off because actually you have more rules to entered into the knowledge base. You have more. You also have to take more time to process the information. This one is a good table to summarize the comparison, the differences between your expert system and the convention system and your human experts. So on the leftmost column here will be your human experts. How does human experts work? How do they how to become why are they experts? So they actually expert because they use the knowledge in the form of rules of thumb, right? So it's a general rules or heuristics to solve problems in a narrow domain. Now, what about the programs in that same area? How does a conventional program process the knowledge? So they process the data and use the algorithms, which is basically a series of well-defined operations to solve a general numerical problem. So this is a numerical problem. This is a narrow domain. Problems in a very specialized field, right? So this is more on, for example, I can't use a program that adds two numbers together, right, to solve my car problem. Now, how about expert systems? The expert systems will process knowledge expressed in the form of rules, and then use the symbolic reasoning to solve problems in a narrow domain as well. So we compare these three, at least for this row, can see that for the expert systems, actually is able to capture some of the similar things in a human expert. Why? Because it actually able to solve problems in a narrow domain as well. Now, what about the human experts? Human experts use heuristics, right? They in the form of rules, rule of thumb. Such knowledge captured in the form of a rule of thumb, and here they also uses knowledge, but now the knowledge is expressed in the form of rules and uses symbolic reasoning, right? So here humans use rules of thumb or heuristics. Expert systems use rules and symbolic reasoning to solve similar type of narrow problems in a narrow domain. But for the conventional program, right? No, they actually uses algorithms, and then this is basically a series of well-defined operations to solve general numerical problems. Now, another area of comparison is the human brain. Now, in the human brain, knowledge exists in a compiled form. This is compiled and stored in our brain. Now, for the right-hand side here, the conventional programs, they do not separate the knowledge from the control structure to process this knowledge. So the knowledge and the control structure are combined together. They do not separate them. You cannot see the separation between the knowledge and the control structure, how you process that information. Now, what about the expert systems? There is a clear separation of knowledge from its processing. I can see here, this is the knowledge and this is the processing. So you can see that it's actually well separated. So if I change all this here, it will not affect my processing. It's similar to what we have in the human brain. So so this one actually you can clearly see that is copying from the human expert, but not there yet, not everything yet, as you'll see later on. In another comparison, we're looking at the human expert. Now, human experts are capable of explaining a line of reasoning and providing the details, how you actually come to a certain conclusion. So it actually tells you how I arrive at the answer by following a line of reasoning, right? And then providing the details of how explaining it, how I arrive at that conclusion. Now, in a conventional program, right, you do not explain how a practical result was obtained and why input data was needed. right? So 1 plus 1 equals to 2. So this is a normal conventional program. So how do I uh, arrive at the answer? I do not tell you. It's not easy, or rather not easy to explain, because you can explain maybe technical way, but not the same. Right? So it's a bit different. Now, the last one is actually the expert system. Now, how about expert systems? How about the reasoning part? So this is more on the where does knowledge exist. This is how the human experts use the knowledge, and this is about explanation. So the expert systems here can trace the rules fired. So you can go back and debug, find out which are the rules that fire, which are the rules that were activated during a problem-solving session. And then at the same time, able to explain to you how a particular conclusion was reached and why a specific data was needed. Why do you need data about the status of your petrol tank? Why do you need status of your battery condition, right? Because I need that because there's a way for me to explain to you why your car cannot start. And then this is a rule that was fired. This was a rule that was activated based on these facts and based on this condition. Therefore, I arrive at this conclusion. So you can clearly see how you arrive at that. So it gives you, in a way, give you a better sense of confidence in actually arriving at that particular answer. Moving along, how about experts? How do we reason, right? So humans, experts, as all of us know, we use a sort of inexact reasoning, and then we can deal with incomplete, uncertain, and even fuzzy information. With information that is not complete, but fuzzy, vague, right? So we can still arrive at a useful conclusion because we use what we call inexact reasoning. Now, what about your conventional program? What happens if the data is missing, right? When the data is not complete, right? So it cannot work. So it can only works on problems where the data is complete or exact. Maybe 1 plus 1 again. Can I say that? Can I use that as an example? Right? Because if the data is not there, it's it won't give you the right answer. So it can only work on problems where the data is complete or exact. Now, what about human experts? Now, the human expert, because we are all along we are saying that the from the human expert way of processing information, processing knowledge. So that therefore it also allows or permits inexact reasoning and can deal with incomplete, uncertain, and fuzzy data. So you can see here is actually now the expert system is able to copy quite well the human experts in terms of reasoning, with incomplete, uncertain, or fuzzy information or data. Right? Now, then how about in terms of making mistakes? Right? So the next one this one is making mistakes. Humans can make mistakes when information is incomplete or fuzzy. Now, so it's actually that is something very obvious for us. We know that if you do not give me, especially do not give me complete information, based on what you've given me, I can still give you an answer, but the answer can be wrong, right? So 1 plus 1 equals to 2. So if I do not tell you that 1 plus something, that 1 plus 1 is not there, the second answer is not, data is not there, I can still, I will not be able to give you a right answer, right? So that is not, you can make mistakes. Now, for the conventional program, so if the data is missing, right? So it can also tell you error, right? So it will crash, right? Crash because the program cannot run. So therefore, it cannot give you answer or give you complete wrong answer when the data is incomplete or fuzzy. So this one is actually difference. It says that can make mistakes. This is actually no solution or wrong solution, right? So it still give answer, but it's not a good answer. But this one actually, it will either give you no answer or give you a wrong answer for the conventional program. Now, what about expert system? I can see here, actually, it's very similar now. So we're able to copy some of the ways that humans process knowledge. That is by making mistakes when the information is not complete or fuzzy. So it's the same thing. So expert systems have these similarities with experts, human experts. That is, it can make mistakes when the data is incomplete or fuzzy. And the next one is looking at the quality of the, how can I improve the quality of my uh, uh, expertise? How do I become a better expert? How do I learn? How do I improve? Right? The human for humans, clearly, the more time you spend, right? In terms of that problem, you will become better. You become a better expert or deeper expert. So now, unfortunately, if you want to enhance your problem solving in that area expertise, in solving for predicting the weather, whether should I bring umbrella or not, should I, what's wrong with my car if my car cannot start, right? To actually learn that skills, right? So if you want to enhance the quality of problem solving, actually it's through years of learning and practical training, right? Both theory and practical. So you can see that in engineering, we actually always have these two parts. One is theory and one is practical, hands-on. You actually apply the theory to your work, right? So one cannot proceed, cannot move without the other, right? So you can't have good practical, good hands-on experience without theory. And if you don't have theory, you do not have, if you don't have practical experience, cannot, you will not know how to apply your theory. That's why engineering, we always emphasize need to have practical labs. That's why you apply your theoretical knowledge into in the problem in real time. So this process, because it takes years of learning and practical training, therefore the process is slow, inefficient, and expensive, because it expensive both in terms of time as well in terms of money, right? You need to train you to become better, so it takes a long while to train, right? So good example is like you guys here. It takes you 3 plus 3, 6 years to become fully qualified to train, become an either the electronic engineer or the mechatronics engineer or electrical engineer. Some of you taking the specialization in electrical engineering. Now, for the conventional programs, you enhance the quality of the problem solving by changing the program code. Right, so you just if you want to improve your program, so you just change the program code, which affects both the knowledge and its processing. So making therefore the changes are not easy to make. So the changes are difficult. So that's how we work, how we improve the quality of my conventional program by changing the program code itself, changing the code itself. So to change the right code is not that easy. So now for expert system, how is it compared to these two ways of doing things? So you can enhance the quality of my expert system by just adding new rules or adjusting, tweaking, refining the old ones in the knowledge base. So you only need to do it over here in my knowledge base on my long-term memory. And of course, the data is actually something we capture from the environment, so you don't have to worry about that. So in order to make the system better, you just change the rules here, because this is the same processor to process the information. So you can enhance by adding new rules or just adjusting or refining the old ones in your data knowledge base. Now, when new knowledge is acquired, so when you find out new things that, in addition to finding out the condition of my battery, I also need to find out the condition of my fuel tank, whether there's a petrol inside my fuel tank or not, right? To make a better prediction, right, on what's wrong with my car, right? So when this new knowledge is acquired, changes are easy to accomplish. You just add the new rules into your knowledge base, or you just refine the bit to the rules. Now the rules will have to include one additional feature to look at, which is your fuel tank. In addition to battery, you look at the fuel tank. So next day you might say, oh, this is still not good enough. I only get 75% accuracy all the time, right? In terms of when the customer comes to see me to ask me what's wrong with my car, I only have this one, these two things to process, and then as a result, I only get 75% accuracy. I am not getting 90% or 100%. What's wrong? So then you find out, oh, I can also find out on for example, if it's the petrol itself, is it petrol or is it the diesel? Is it the right petrol? Right, because if a petrol car cannot run on a diesel and vice versa, the diesel car cannot run on petrol. So there's also another rule you need to tweak. So it's something you found out recently, and then of course you need to add on to the old rules, or add on or change the old rule to include this one. Right. So again, these are when such new knowledge is acquired. So it's quite easy to change the system, right? You just change the rules. So unlike the conventional program, you need to change the codes, the program codes. So this is actually easy itself. So you can see this one has a benefit compared to my human expert, because the process actually for me to learn new things takes a long time. It's slow, inefficient, and of course expensive. But the expert system is actually faster. So this will be one of the benefits of your expert system compared to human, right? Other than this, these two are the same, right? The exact reasoning is the same, make mistakes is the same. But of course, you can see conventional programs now actually is not suitable for the to be an intelligent system for this purpose of expert system. Okay, I think we should stop here, because if I go into this, I will not have the time to complete this. So I'll stop here. So when we come back on next week, Wednesday. By the way, can I check with you guys? Are you having workshop in the morning next Wednesday? Today is 16, 16, 17, 31st of July. Are you having a workshop in the morning? If not, can I have the, I think it's very tricky. I need to check. I still owe you guys a replacement class, a 1 hour lecture. So I need to look at it. Never mind. I think I'll wait until maybe early August to have a replacement class. It's safer that way. Okay. Now, before I end this morning's lecture, are there any questions you want to ask me? Right? Any questions, comments? Welcome. Right? If not, we can end the class here, and I'll see you back. I think next week we have what do you call it? We have the lab, isn't it? On Monday, starting the lab again. Anything? Okay. If not, enjoy your weekend, and I'll see you back next week. Thank you. Bye bye.
Thank you, sir. Bye bye.
Thank you, sir.